Hi students, problem number 8. A simple pendulum has a time period T1. When its point of suspension is moved vertically upwards according as y equal to kt square, where y is the vertical distance covered and k equal to 1 meter per second square. Its time period becomes T2. Then what is T1 square by T2 square by assuming g equal to 10 meter per second square. So very interesting numerical problem. It has been asked in the IIT in the previous years. Now look at the situation first. When the pendulum is in equilibrium, that is not disturbed, when it is at rest, its acceleration due to gravity, only acceleration is due to gravity. When such a pendulum is oscillating, then we have studied its period of oscillation is t equal to 2 pi into square root of L by G, is it not? So let us take L is the length of the string. Now while it is oscillating, it is accelerated upwards as per this equation y equal to kt square. It is similar to that of suspending a simple pendulum at the ceiling of a lift which is moving upwards with an acceleration. Okay. So in the second picture you can see that with respect to its mean position, O, the point of suspension is accelerating upwards as per this equation. So what is the equation given? You see here, y is equal to, its displacement y is equal to k times t square. So if you differentiate this equation, we get dy by dt, okay, dy by dt, that is equal to velocity. So that is k into 2t, k into 2t. So this is equal to 2 into k into t. Once again, if I will differentiate this, then d square y by dt square, that is equal to acceleration. The second derivative of displacement is what? Acceleration. So 2k is constant, t is the variable. Therefore, we get what? 2 into k. But what is the value of k? They have given k is equal to 1. Is it not? Therefore, acceleration is equal to 2 into 1, that is equal to 2 meters per second square. This is the first step. So, what is the upward acceleration of the string? That is a. That is equal to how much? 2 meters per second square. I hope up to this you must have understood. So, in the second picture, there are two accelerations, isn't it? G downwards, A upwards. So, same like that of a lift man's apparent weight when he is moving upward is m into G plus A. Is it not that? So, now let its acceleration, net acceleration be G dash. Okay, let it be G dash. So, as usual, I am going to write two equations. You see here T is equal to 2 pi into square root of L by G in the first case. In the second case, T dash is equal to 2 pi into square root of L by G dash. So, here G dash is equal to what? G plus A. Okay. So, G dash is equal to G plus A. Now, you can see here 2 pi and root L is constant. So, I can write T is proportional to 1 by root G and T dash is proportional to 1 by root of G dash. So, T is proportional to 1 by square root of G and T dash is proportional to 1 by square root of G dash. Okay, now here T1 square by T2 square is to be determined. So, I will take the ratio T1 by T dash. So, T1 divided by T divided by T dash is equal to square root of, now T divided by T dash. So, this will be what? G dash divided by G. Okay. Now, G dash is equal to G plus A. What is the value of A we have found? 2 meter per second square. What is the value of G given here? 10. So here I have to substitute this is equal to 10 plus 2, that is equal to what? 12 meter per second square. So in place of G dash, I can substitute in the numerator 12 meter per second square, and in the denominator for G I can substitute 10. So this is now equal to square root of 12 divided by 10. 6 2s are 12, 5 2s are 10. So this is equal to square root of 6 divided by 5. Now you square on both sides, okay? Therefore, t square by t dash square, or as given here I will take. So this is t1 and this is t2. So this is t1, I will take it as a t2. Okay, so t1 square by t2 square is equal to, this square root will vanish. So we get the answer what? 6 by 5 is the answer. So now which is the option? Correct option is 6 by 5. So option C is the correct answer. Okay, well, therefore option C is the correct answer. I hope you must have understood the fine.